So good afternoon, and today we're going to talk about the applications of calculus. So my name is Christopher Tungsten, and my student ID is EGE2409037. So today we're going to discuss the first going to be the application of derivative in economy, which is the cost, average cost, revenue, average revenue, profit, and average profit. All is the functions. And later I'm going to give three examples of the marginal analysis. The second is going to be the washes methods, which is finding the volume of solids of revolutions. And later I'm also going to give the example of the calculation. Sorry. And the last is the moment and the center of mass. Yeah. So definitions and the formula will be explained for later. And also the example for the center of mass will be provided later. So now is the application of derivative in economy. The first is the cost functions. Derivative of cost functions measures the marginal cost, which represented the additional cost of producing one more units. The second is the revenue functions. The derivative of revenue functions measure a marginal revenue or the additional revenue from selling one or more units. Selling one more units. The third is the profit functions. The profit function is given by the Px equals to Rx minus Cx, and its derivative the P prime x, determining the rate of change of profits. The fourth is gonna be the average cost, which is measured how the average cost change with the productions. So as you can see, the formula is the ACX is equal to CX over X. And the fifth is gonna be the average revenue, which is measure the change in revenue per unit sold. And the formula is ARX equals to RX over X. And last is the average profits, which is help to determine the change in profit per units. And the formula is APX equals to PX over X. And now I'm going to give three examples for the functions. Okay, so for the first is going to be the cost function. As you can see, Cx equals to 5x squared plus 10x plus hundreds. So for the C prime, it's going to be 10x plus x, plus 10. The second is the Werner functions. Rx equals to 20x minus x squared. And R prime is going to be 20 minus 2x. And the third is the profit functions. Px equals to negative 2x squared plus 20x minus 50. P prime and the next step is going to be P prime x equals to minus 4x plus 20. So now it's going to be the Washes methods for volume of solid and revolutions. And this revolution is used to find the volume of the solid formed by the revolving a region around an axis. As you can see the functions, as you can see the formula, V equals to prime integration from A to B, a big bracket of the Rx squared minus the small Rx squared, and the close big bracket dx. So from the Rx gonna be the outer radius. From the small x gonna be the inner radius. So this is to identify the region and axis for rotations. Determine the Rx, which is the outer radius, and the small Rx, which is the inner radius. And the last gonna be to integrate using the formula. So this is the example of the washes methods. So the question is gonna be find the volume of the solids formed by the whirling the region between y equals to square root of x and y equals to x around the x-axis from x equals to 0 to x equals to 1. So at first we're going to use the formula which is the washes method. V equals to prime integration from 0 to 1 big bracket of a square root of x squared and minus the x squared close big bracket dx. And the second step is going to be the prime integration from 0 to 1 bracket x minus x squared and close bracket dx. The third step is going to be v equals to prime x squared over 2 minus x cubed over 3 integration of 1 to 0. And the last step is going to be prime bracket 1 over 2 minus 1 over 3, which is equal to pi over 6. So now it's going to be the moment and center of mass. So the moment and center of mass is measure the distributions of mass relative to a point or axis. The center of the mass, x bar and the y bar, is the point where the mass is balanced. The x bar is equal to the m small y over the big M, and the y bar is equal to m small x over the big M. And now it's going to be the example for the moment of and mass. Now it's going to be the example of the moment and center of mass. So the question is about to find the center of the mass for a lamina occupying the region x smaller or equal to 0 smaller or equal to x, and x smaller or equal to 2, and 0 smaller or equal to y, and y is smaller or equal to 1, with the density function of x delta of x y equals to 1. So the first gonna be the mass. M equals to integration of 0 to 2 and the integrations of 0 to 1 delta of xy dy dx is equal to the integration of 0 of 2 and the integration of 0 of 1 dy dx is equal to 2. For the moment, it's going to be the mx is equal to the integration of 0 to 2 and the integration to 0 to 1 y dy dx is equal to 1. And the my is going to be the integration of 0 to 2 and the integrations of 0 to 1 x dy dx is equal to 2. And the last step is the x bar is equal to my over m, which is equal to 1. And the y bar is equal to mx over the m, which is equal to 0.5. Okay, so now it's the conclusions. Derivative provide the valuable insight into the economic functions. The Washer methods simplify the volume calculation for solid of revolutions. Moment and center of mass revolve the balance point in the physical and engineering. Okay, so this is the end of my presentations. Thank you very much.